Okay, sir. So let's start the class. Today's class. So today we are going to discuss about the RH method, case number 2. So in the previous video, in the previous class, we discussed about the RH method, case 1. So what is case number 1? If the first element of the row will become 0 and there must be another non-zero element in the row. So then we are going to consider that one as a what? Case number 1. So what is number case number 2? Here, so this is a, let us see, this is an array. So I have taken an example. So as we know how to write the array. So first two rows I am going to write with the help of the characteristic equation. Later rows I am going to use the RH method. So we are going to identify the next row. So suppose by solving, if you get the all the elements become 0. So here, so s to the power of 3 term, so all the elements are becoming a 0. So this one we are going to call as what? Rows of zeros. Then how to complete the array? So we can't able to complete the array, right? So that's why we are going to take the previous row as a auxiliary equation. Okay? So which is the previous row? It is s to the power of 4. That is the previous row, right? So this row I am going to consider the auxiliary equation. So I am going to write the equation. So auxiliary equation is equal to ds square, s to the power 4. Why it is ds to the power of 4? The highest order is s to the power of 4. So that's why ds to the power of 4 plus. So we are going to write alternate, right? So next will be e s to the power 2 plus f s to the power of 0. See 4 to 0 alternate. Did you got it? So this one is called as what? Auxiliary equation. So now I am going to differentiate this equation. So that is d by ds of this auxiliary equation. What is the after differentiation with respect to s? So this will be 4d s to the power of 3 plus 2e s to the power of 1. So this will be right. So this is how I am going to consider the auxiliary equation, and I am going to differentiate the auxiliary equation with respect to yes. I am going to get this equation. So now what I am going to do, instead of s to the power of 3, so I am going to rewrite the array s to the power of 5, a, b, c, s to the power of 4, d, e, f. Next s to the power of 3. What is s to the power of 3 now? What is the coefficient of s to the power of 3 here? 4d. What is the coefficient of 2e s to the power of 1? Sorry, s to the power of 1, 2e. 2e and this one is 0. So I completed the row, right? S to the power of 3. Next I need to write s to the power of 2 with the help of previous 2. And I am going to continue. So this is what the case number 2. What is case number 2? When the complete row becomes 0, then previous row I need to consider as an auxiliary equation. I need to write the auxiliary equation and I need to differentiate the auxiliary equation with respect to s. I am going to get the next s to the power of 3 order. Is it clear? Yes. Then I am going to complete the array. So this is what the case number 2. Is it clear? Yes, sir. So shall we solve the problem on this? Yes, sir. Yes, please take it. Okay, sir. So the characteristic equation of the system is being given. So now we need to check whether the system is stable or not by using the RH method. That is the question. So now we have a characteristic equation. So as per the rules, so none of the terms should vanish. Okay. So the order of the s must go from decreasing order, right? So here, so we have s to the power of 8, but we don't have s to the power of 7. So therefore, we need to write the characteristic equation. So the characteristic equation will be s to the power of 8 plus 0 s to the power of 7 plus 5 s to the power of 6 Next one, 0 s to the power of 5, 2 s to the power of 4 plus 0 s to the power of 3 plus 3 s to the power of 2 plus 0 s to the power of 1 plus 1 is equal to 0. Right? So as the rule says, none of the terms should vanish. So that's why we have written the missing coefficient, right? So therefore I am going to start with the array. So the highest order is s to the power of 8. So the coefficient of s to the power of 8 is 1. So next it will be 5. Next it will be 2. Next it will be 3. Next will be 1. Correct? So now, what is the coefficient of s to the power of 7 and 0, 0, 0, 0, 0. Is it clear? Yes, sir. So this is the case number 2. That means this is a row of 0. So I am unable to complete the array. So then what I need to do? I need to consider the previous row as an auxiliary equation. This is an auxiliary equation. So therefore, what is the auxiliary equation? The same thing, right? S to the power of 8 plus 5s to the power of 6 plus 2s to the power of 4 plus 3s to the power of 2 plus 1 is equal to 0. The previous row itself is the auxiliary equation. Now what I need to do? I need to derive, differentiate, right? Sorry. Differentiate with respect to s. So d by ds as is equal to what? 8 s to the power of 7. 6 5 is 30 s to the power of 5. 8 s to the power of 3. 6 s to the power of 1 plus 0 is equal to 0. Is it clear? Yes, sir. So now I am going to redraw the array. Okay? So I am going to rewrite the array here. So I will continue here only. But I will erase this here only. But so when you want to get the marks, you need to write step by step. Okay. So what is the coefficient of s to the power of 7 with this equation? So it will be 8. Next one 30. Next one 8. Next one 6 and 0. Now I got the two rows, right? So now I am going to continue this. How? So what is this? S to the power of 6. So s to the power of 5, s to the power of 4, 3, 2, 1, and I need to write the s to the power of 0. So how to continue this? 8 into 5 minus 30 into 1 divided by 8. So like that you need to complete the array. Right? Please try to do it and tell me the answer. Now please tell me the next row. 1.25. Yes, please make the point. Yes, 1.25. 25. 1. 2.25. 2.25. 2.25 1 0 0 23.6 minus 0.6.4 minus 6.4 next term minus 0.4 next term 0 1.34 okay 2.27 okay 1 0 minus 46.38 minus 46.38 minus 18.01 0. 1.7. 1.55. 1. 0. 8.5. 0. 1. Sure na? Everyone got the answer?
Yes, sir.
See, after applying the rules, so we have created the array. So now how to identify whether the system is stable or not? So we need to consider the first column of the array. So if there is any sign changes, then the system is unstable. Okay. So do you have sign changes? Yes. So here up to here it is plus. So plus to minus, then minus to plus. So how many times the sign is getting changed?
2 times.
Right. So that means out of 8 roots, 2 roots are lying to the right side of the display, and remaining 6 roots are lying to the left side of the display. So that is what the comment on stability. So the system is unstable. Is it clear? So this is how we are going to solve the RH method special case number, that is rows of zeros. Okay na? Okay. Let us take the next problem. So in this problem, so the characteristic equation of the system is being given. So now the question is that we need to find out the number of roots with positive real parts, negative real parts, and zero real parts. So that is what the question is. So for that, so as usual, we are going to apply the RH method. So first you need to know whether any of the term is vanishing or not. Any term is vanishing? Yes. That is, here the term is vanishing. That is 0 is to the power of 3. So this term is vanishing. I am going to redraw the characteristic equation. After redrawing the characteristic equation, I am going to write the RH method. I am going to write the RH. So help me in writing array. X to the power of 6, that will be equal to 1, 3,
minus 16,
minus 16,
minus 48.
minus 48. Next is to the power of 5. That is 4, 0, minus 64, 0. Next is to the power of 3, is to the power of 2, is to the power of 1, and is to the power of 0. So 4 3s are 12, minus 0 divided by 4. So this will be equal to 3.
Sir, S to the power 6, S to the power 5, S to the power 4.
Yes, 4, 3, 2, 1, and 2. So here S to the power of 4 is how much? 3. Correct?
Yes, sir.
So what is this?
32.
4 into minus 16 minus into minus of 64 into 1 divided by 4. How much is this?
0.
Please complete the array. Okay, and please let me know the answers. Complete the array. Rakesh, so please tell me the row of x to the power of 4. 3, 0, minus 48, 0 na. Next x to the power of 3. So here when you apply the rules, the x to the power of 3 becomes what? 0, 0, 0. Right? So therefore this is a rows of 0. So this is special case number 2. So therefore what is the auxiliary equation? Auxiliary equation 3 is to the power of 4, 0 is to the power of 2. Next, minus 48 is to the power of 0. So this is the auxiliary equation. Why this is the auxiliary equation? This is the rows of zeros. I am going to consider the previous row. So I am going to write the equation with the help of this previous row. So this is the equation with respect to the previous row. So this is the auxiliary equation. Is it clear?
Yes,
so now I am going to differentiate this auxiliary equation with respect to d by ds of what is this? 12 s cube. So this will be 0 and 0. Okay. So instead of rows of zeros, what I am going to do? I am going to write the coefficient of the derivative. So that will be equal to how much? 12. Right? So this will be 0, 0. Next, what is the row of s to the power of 2? 0 minus 48. Next, 0, 0. 0. So that means, so now what is the next thing? So this is the case number 1. What is this case number 1? The first element of the row is 0. And there must be another non-zero element. So do you have another non-zero element?
Yes, sir.
Yes, we have another non-zero element. So therefore I am going to apply the case number 1. How to solve this? I am going to replace this 0 with another non-zero element, small non-zero element, that is the epsilon. I am going to complete the array epsilon into 0 minus 48 into 12 divided by epsilon. How much is this? Minus 576 divided by epsilon. Next one.
0.
This one is 0. What about this one?
27648.
Sorry?
27648.
27648. Is it right?
48.
Oh, correct idea.
Minus 48 minus 4. 48.
So this element into this, right? Minus this into this, divided by this. So there will be minus 48. Correct? Is it minus 48, right?
Yes, sir.
Is that right?
Yes, sir.
Okay. So now we have completed the array. See, in this problem we came across the case number 2, right? With rows of zeros, and also we came across the case number 1. So that means what is the case number 1? First element of the row is 0, and there must be another non-zero element in that row. So then only we are going to replace the epsilon. Okay. So now I need to identify whether this is a negative value or a positive value. Right? How to do it? I am going to apply the limit. Limit epsilon tends to 0. So this is minus 576 divided by 0. Sorry, epsilon is there. So if I apply the epsilon is equal to 0, how much is this? Minus infinity, right? So I have a negative sign here. So divided by something is 0. So this will be a negative infinity. So therefore this is a negative element. Negative. Okay. So now the system is what? Unstable. So in the equation only we can identify the system is unstable. The same thing we got it. So now the what they are telling is we need to find out the number of positive roots and roots with the positive real what is the positive real part and the negative real part and also zero real part. So that is what we need to find out. So here I am going to consider the auxiliary equation. Which is the auxiliary equation? This itself is an auxiliary equation, right? So auxiliary equation is 3s to the power of 4 plus 0s square minus 48s is equal to what? I am going to consider this equal to e 0. Why? To find out the roots, whether it is a positive or a negative. Okay. So therefore, so I can write this one as what? So this one is s to the power of 0, right? So this we can write as 3s to the power of 4 is equal to 48. Correct? So therefore, what is s to the power of 4? 48 divided by 3, how much?
16.
Huh?
16.
16, huh? 16. Right? So s to the power of 4 is equal to 16. So now, so I am going to replace s to the power of 2 is equal to y. In this equation, I am going to replace s to the power of 4. Sorry, s to the power of 2 is equal to y. So therefore, what happens? What happens? So this can be written as what? Y square is equal to 16. Is it right? So why? Because I am taking s to the power of 2 is equal to y. S to the power of 2 is equal to 16. Right? Is it right? Why? Because s to the power of 2 is equal to y. So I have s to the power of 4. So therefore here, so if I shift this power to that one, so this will be plus or minus, sorry, plus or minus 4. So y is equal to plus or minus 4. So what is y? S square is equal to 4 and another s square is equal to minus 4. Is it clear? So therefore, what is s here? Plus or minus 2. What is s here? Plus or minus 2y. Imaginary. Plus or minus 2i. Did you got it?
Yes, sir.
See, I need to find out what are things I need to find out. Roots with positive real part. Correct? So next I need to find out roots with negative real part. Next, roots with what? With 0 real part. Correct? See here I have two imaginary axes, right? Plus or minus 2i. That's an imaginary number. So that is with a 0 real part. Yes or no? We don't have any real part in this imaginary number. Right? So that means how many roots with 0 real parts? 2. Plus or minus 2i. That is s is equal to plus 2i and s is equal to minus 2i. So these are the two roots which is having 0 real parts. Okay, therefore number is equal to how much? 2. Okay, so here I got s is equal to plus or minus. So I got plus 2, right? Right? S is equal to plus 2. So that means one positive. Roots with positive real part is how much? Correct? So now as we know the system is what? Unstable. Correct, Alva? So now the roots with negative real parts, how much? So totally how many roots I have? Totally how many roots I have? What is the highest power? 6. Right? Out of which minus 2 is 1, minus 1 is there, right? So what is the minus 2 represents? Roots with 0 real parts. That is minus 2. Roots with positive real part. How much is? Minus 1. So therefore, what is the value? 3. That means remaining roots. How many roots? Roots with negative real part is equal to. Okay. So this is how we are going to find out the number of roots with positive real parts, number of roots with the negative real parts, and number of roots with zero real parts. Is it clear?